All right, we're back. We are COMP397. That's web game programming in the winter 2018 semester at Centennial, and we are week 6, part 2 of our broadcast. We're talking about frame-based animation with CreateJS. So what the heck am I talking about, right? First of all, what is animation? Why am I doing it? Well, let's think about this. So far in our code, we have in our core game.ts file, we have all of this stuff. And one of the things I want to do, it's not just animations I want to talk about. I guess it's kind of the wrong name. But I also want to preload. I want to have all these files for the most part, other than maybe the ocean. I want to have all this in one file. Imagine if I have to preload each individual file. Here, it's okay. I only have maybe, what, 10 files or 15 files? Who cares, right? But what if in a larger project, let's say Alexi here is, he's making a bigger game, right? Something more realistic. And, or maybe it's not a game, it's an application, right? And you want to preload some of your images and your assets. But you have, instead of 15 assets, you have 1,500 assets, okay? Are you going to go list it like this? It's crazy, right? It's too long, right? So we have to make sense of how can we put a lot of these assets on one page, on one sprite sheet, okay? So in order for me to talk about sprite sheets, you're going to need to know what sprites are, right? So first of all, let's see what an example of a sprite sheet might look like on the web. So if I kind of hunt for sprite sheet, I can see that. Let's look at this Mega Man. Here's Mega Man sprite sheet, right? You can see here's Mega Man. And this is what a sprite sheet might look like in a second. I'm just going to a random site, by the way, just because I wanted to show you it. But yeah, that's not what I wanted. It means just this, okay? So this is what I want. So basically you have one sheet. This is one texture. Remember we talked about images? Images or a bitmap. I like in CG, computer graphics, we call them textures. That's the name for them. So I have a texture, but on one texture, instead of having one image, I have many images on my texture. Okay. And in this case, what I have is a bunch of images. I'm just going to zoom in here so you can see this. A bunch of images here of Mega Man in different poses, right? This is one use of a sprite sheet. But you can also put a lot of other things on a sprite sheet, okay? Let's look at some other sprite sheets. Here's some other sprite sheets. This looks like a bunch of poses, right, for a character. So I've got a character here, right, and he's got different poses. Okay, well, how do I use this character? Because I have each of these poses, let's call them frames, right? Each of these frames, these are frames, right? Different poses. And, well, how do I get from this frame to this frame? So let's suppose these are, let's call them keyframes. These are keyframes, right? And I want to move from this frame to this frame, from this pose to this pose. I need to do the in-between frames. So they're called in-betweens. So back in the day, when we did animations where animators actually made movies, all the terms we're using today, a lot of them that we use in video games come from the movie industry, right? So when we were doing animations, like for example, things like, I'm gonna look at another one, one that's very popular, like Fantasia. Okay, Fantasia is a Disney animation. Hopefully we'll pull up the right thing. A Fantasia film, not some other Fantasia. Right, so film. And if we look at images for Fantasia, it looks like this. Mickey Mouse, right? And he had some classic animation, and it looked like, Mickey Mouse was moving around on the screen. It's one of Disney's first films, right? But the way it looked like Mickey Mouse was moving around the screen is an artist physically drew Mickey Mouse, right, a bunch of times, over and over again, right, in different cells that represented each, part of the film. So each cell, right, or each frame of the film, right, Mickey Mouse is being drawn in different poses, right? So you had an artist, and he would draw the keyframe, the main pose. Then he would draw another keyframe, another pose. And then you had another artist, or maybe a group of artists, that would draw all the in-betweens. right? All the frames in between, they're called in between. And these were called tween artists, right? And they would go through and just basically redraw everything. Now, back in the day, animators who were keyframe animators got paid a lot more money. And what they did was they farmed out, or they contracted out the keyframe, the in-between frames, to somebody else. Usually someplace in Japan, China, India, someplace that was less expensive to do than in the West, typically, right? So you farmed out this stuff. So you had your keyframes, and you gave the in-betweens to somebody else to do. And every single cell was drawn by hand. Okay, so that's how it was done. So, and you had other roles too. You had your lead animator. You had your art director. You had your director. You had your script writer. All these people, right, to make the film. And usually, if you think about a film, and let's say Fantasia here, right? So if we go back to Fantasia, and if I look at the film itself, this is 1940. Okay, was done. I'm just using Wikipedia here for educational purposes. So this film was 126 minutes. The budget was $2.28 million, right? And in the box office, it brought in something like 76 million. This is back in 1940, guys. All right, so it was a big revolution for Disney. Disney made a lot of money from this film back then. And the reason why it did this is because it was revolutionary. No one had seen something like this before, right? And, well, this is good. But let's think about this. 126 minutes, okay? And we have this thing. Humans have a problem. It's called persistence of vision. It's not a problem. It's so how fast our vision can refresh. We have little screens in our eyes, let's just suppose, right? And our eyes refresh. We have a refresh rate, okay? Anything beyond 24 frames per second, human persistence of vision, you can't detect the difference. Anything beyond 24 frames. And for you to look up, if you're interested in human persistence of vision, you can look that up. Okay, human persistence of vision. And what it does is it kind of creates this idea of what it says here, an optical illusion, right? That looks like it's continuous. The motion of the frames are continuous. That's what it looks like. But actually they're not. We're flipping between frames. Frame-based animation means I have a frame, and then I flip to the next frame. Then I flip to the next frame, the next frame, the next frame, until it looks like it's natural. And it does it so many times per second. So 24 frames per second, or if you think about this, 24 hertz, going back to mechanical, right? 24 hertz. If I go to 24 frames per second, beyond that point, humans can't tell the difference. Video games, old video games, operated around 30 frames per second. Newer video games operate between 60 and 90 frames per second, right? And VR games are at 120 frames per second and more, right? And the reason for this is because, not because of human persistence of vision. The human persistence of vision hasn't changed. It's not like we got smarter somehow, or our people have evolved, right? So we can see better and faster hertz. It's not like that. It's because every frame now we do calculations. In an interactive medium like games, we do calculations every frame, right? The more frames, the more we're able to calculate. And also we're able to adjust, because sometimes we can't deliver the frame rate that we want. So example, we have a frame rate of 60 frames per second for your game right now. But are you getting 60 frames per second? Maybe, maybe not. It depends on the device. It's device dependent, right? Maybe on my cell phone, I'm not getting 60 frames per second, right? But on my smartphone. But what about on a console? Maybe you are. Even today, with AAA games being made, you sometimes have this problem with frame rate, okay? You can't keep the frame rate going because of all the calculations that you're trying to do every frame. So going back to that, so Fantasia had all these frames. So let's suppose that Disney did 24 frames per second. 24 frames per second, right? Okay, for 1 minute is 60 times that. So if I want to see how many frames per minute, okay, let's just try this out. So I'm going to bring up the calculator here. Here's my calculator, my trusty little Mac calculator, right? So I've got 24 frames per second. Let's assume that that's the level, that's the threshold that we can see, right? And then I multiply that by 60, so that's how many frames per minute, right? And I multiply that by 126 minutes, right? So we have 181,440 frames that animators have to actually, draw by hand for this movie. 181,000 little pictures, right? And that's just for each character. So imagine if I have lots of stuff going on in the scene. I have a character. I have, he has a broom. He brushes stuff. There's dust. All those things in the scene have to be drawn 181,440 times at least to make this film look natural. Okay, and the backgrounds were also separate. So you had separate background, and those had to be moved around in the frame in the background. So you had the animators animating the characters, and then you had the background artists and the concept artists moving things around in the background. And that's why films, my friends, especially animations, actually any film nowadays, because, hey, guess what? If I want to do a special effect in a real live action film, I want to do lightning from my hands, frame-based animation. Lightning from my hands, right? If I want to teleport, right? Frame-based animation, so to speak, okay? Nowadays, of course, we don't draw 181,440 frames because movies are digital, right? We do the keyframes a lot of times, and then we have a machine, have an algorithm, do some of the in-betweens. And I say some of because the artist still has to be in there, right? Especially for animation, to go through it and go, wait a minute, that doesn't look right. The computer didn't calculate this correctly. It didn't linearly interpolate, right? Between this frame and this frame, and then they'd make some adjustments. This same thing they do in special effects, and the same thing they do in video games. The same kind of idea, right? But we don't draw 180,000 frames anymore by hand. Typically, there's a little bit less. Okay, still a lot of this because some of the stuff that are being drawn, especially in classical animation, not computer animation, is not done by the computer. It's done by hand. Still, in computer animation, there's more linear interpolation between one frame and the other. Between two keyframes, the computer does a lot of the stuff in between. Our program, CreateJS, the framework we're using, or the suite of frameworks. If I go to CreateJS, suite of libraries here, has TweenJS. And now you know where that name came from, TweenJS, from in-betweens. It actually does some interesting linear interpolation and movement between one frame and another. We're not going to do a lot of TweenJS in this course, right? But if you wanted to, you could use TweenJS for smooth motion or transitions from one state to the other. It's really, really cool. Again, we may not have time to hit it this semester. But we can do a lot of it with Easel.js. Easel.js allows us to create something called sprite sheets and sprites, right? And with sprites, sprites are not just bitmaps. Bitmaps, if you think about it, they're textures, right? We talked about bitmap class as a texture, right? Bitmap is, accesses a JPEG or a PNG image, and then we load it in data. It's a data buffer, all right? Think of it this way, right? Big data buffer. But we can only do so much with bitmaps. Sprites have more information attached to them. Here's a sprite. So it's like a bitmap, right? It's still a display object, but what it allows us to do is take a little image and put it into a larger object, a sprite sheet, right? So going back to sprite sheets, imagine I have this caveman here, right? And I want to animate between this keyframe and this keyframe. What I'm going to do is the computer is going to do all the in-betweens. All the frames in between one keyframe and another, the computer is going to interpolate. It's going to draw or render all of those images, right? Our algorithm is going to do it for us. So it's going to look natural as can be, okay? The more keyframes you have, the more natural it's going to look for the computer because there's less interpolation between one keyframe and another. So if I have an animation, for example, this thing here, let's take a look at this. It's only from here to here, there's 1, 2, 3, 4, 5, 6, 6, let's say 6 keyframes for his walk cycle. This is his walk cycle from here to here, and then he's back to this again, okay? And it repeats over and over again, right? So 6 frames. Let's figure this out now. If my walk cycle is 6 frames and my frame rate for my game is 60 frames, how many times does my walk cycle repeat? 10 times, right? I have 6 frames for my walk cycle, 60 frames for my frame rate. So my walk cycle will repeat 10 times in a second. That might be pretty fast, right? We may want to reduce that. So each animation can have its own frame rate. If I have a frame rate for the game, how fast I do calculations. And I have a frame rate for my animations, how fast I switch between one keyframe and another, right? How fast I interpolate between one and another, okay? And the more keyframes I have, for example, this little elf here, I have this walk cycle is many, many more frames. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be smoother, right? And slower. Because I have more frames for the animation in the same time, right? So it's a lot smoother, but the whole walk cycle will look a little slower. The more frames I have, the slower things will look a little bit generally, and the smoother there will be because there's going to be less work for the computer to do, less between the two frames. So of course, some of you might say, why don't I just use 60 keyframes? 60 frames, 60 keyframes. That means you have to have 60 different versions of a walk cycle. 60. That's not efficient, guys. And I have to load 60 images in the computer at the same time. So we don't never do 60 images. We usually have some kind of portion of the walk cycle, usually between 8 and 12 max. Okay? And you can see there's a lot of other ones. There's a lot of different keyframes you can use. You can use keyframe animation for explosions. We can use keyframe animation for attacks, defenses. So think about all the different cycles. I can have a walk cycle. I can have an idle cycle. I can have a jump cycle. I can have a fall cycle. I can have a getting hit cycle. I can have a getting killed cycle. I can have getting up cycle. I can have a switch weapon cycle. I can keep going, right? And all this can be on one sprite sheet. But I want to be able to access where the next frame is going to be on the sprite sheet, right? Because I want to switch between these things sometimes. And the way to do that is to have a map. I want to have a map of my sprite sheet. Another name for a sprite sheet is a texture atlas. A texture atlas. I have a texture, but I have many little textures inside of it, right? So I need a map to point to my textures inside. So I have a texture atlas, and I have a texture atlas map file. 2 files, the PNG file and some other file that points to everything in the PNG that tells the computer or my program where everything is. Okay, are we clear? I know it's a big explanation, but if I was to try and implement animation without this, you'd be like, why is Tom doing this? How come? Why are we doing this? And of course, we don't want, imagine if I had each one of these objects in its own file. Okay, that's another way I could do it. So I have 60, let's say I have 60 plus little drawings here, right? And I have 60 files. I have to load all of them up at once. That's a lot of loading. And if I did this, for every cycle, okay? So if I did, let's say 12 lines for the walk cycle, 12 lines for the fall cycle, 12 lines for the jump cycle, 12, you get what I'm saying, right? That's a lot of lines where I can make mistakes typing, right? A lot of lines that might be wrong. A lot of lines that I gotta have, it's all in my code. All this stuff is in code, right? Lots of lines of code, slower loading. So the solution is using a sprite sheet. But we need some tools to help us. And one of the tools that I use a lot is TexturePacker. So I'm gonna introduce you to this new tool, TexturePacker. It is a commercial tool, okay? This is not a tool that's free. I've used some free tools in the past, and the problem with free tools that do the same thing as TexturePacker is they're not as good. They're not as good, and it takes a lot more time to make them work properly. So what TexturePacker does is, by the way, there is a 7-day trial for TexturePacker, and I think it's a great little program to use. These guys, codeandweb.com, make it. It looks like this. Now, sometimes, I believe the machines in front of you on the Mac side of the house. If you switch to the Mac, they have TexturePacker on the machines in front of you, okay? But this is what it looks like. It looks like this, okay? And notice I have different frameworks that I can export my files for, okay? I can do it for Unity. I can do it for Cocos 2D. I can do it for Sprite Kit. I can do it for a bunch of different frameworks, okay? Even for Unity and for Unreal and for other ones, okay? So if you're someone who's a game person, TexturePacker is for you. if you do any kind of 2D game, at some point in your life, you should buy TexturePacker. I'm not someone who works for TexturePacker. I don't get any money from them. But I'm telling you, it's a very good product. It's solid. Why is it solid? Because it's a drag and drop environment. Now, you could make your own little application. And if you're that kind of person and you're so inclined to make your own little app, go ahead. But you need some way of determining, hey, here's my sprites. Where are they in my sprite sheet? Where are they? I need to know the locations, how wide they are, how big they are, where are they located? Here, all I have to do is drag and drop. So I'm going to go to my stuff online. So I'm going to go to my desktop. On there, I have my COMP397, and here's my mail pilot D. And I'm going to go to my assets, and I'm going to go to my images, and you're going to see that I have some objects. Well, I know I want to include my back button. Sorry, my back button. My restart button and my start button. So let's add them first. I'm just going to drag and drop them in. So start button, restart button. And I'm going to drag my cloud in and my islands and my plane. But look, I have 3 planes. I'll tell you what these are in a second. But these are different states of animation. All right, so this is my first animation we're going to do together. 3 planes, okay? 3. This one is the single plane. The 3, these ones are the animations that I'm going to use. All right, so now it looks like something like this. Let me just bring this out so you can see it. And it's okay. And what it does is trying to position everything on this sprite sheet or texture atlas. That's what this thing is, texture atlas. Good thing about computer graphics, if you know anything about computer graphics, it likes power of 2, right? It likes to be in a proportionate, like 512 by 512, or 1024 by 1024, or 2048 by 2048. It doesn't like this, 494 by 180, right? Because this is going to be a vertex buffer, pretty much, right? A buffer. That's what it's going to be. It's going to be a buffer of data, right? And this data is going to be held in memory. And then I'm just going to access one part of that memory. That's what I'm going to be doing. So I need to make some changes here. I'm going to go to where it says max rex. I'm going to go to basic. Yeah, this is basic. I'm going to change my advanced settings here, right? I'm going to go into my layout, and instead of any size, I'm going to go to power of 2, okay? Where it says 2048 by 2048. That's the max size. If you look, there's also scaling variants if you want to do that. I'm not going to do the scaling variants, but you can have different scales for different sizes. What you can do is you can have multiple images for different sizes. If you're making something for a phone, you're going to have something for a smaller phone, a bigger a phone with more resolution, a phone with the most resolution, maybe a different size screen, a big screen, a smaller screen, because if you have the same images for bigger screens, it's going to look pixelated. So you might have to include other images here, right? Algorithm is basic. Again, I can go with, if I choose max rex, you can see that what it does is it changes the algorithm, right? Sort by, again, by name. I can sort by name if I want. So it's going to be cloud, island, plane, and restart and start. Sort by name. Sort in order. You can see the type of format. I'm using ping32 format. There's other formats you can save your PNG texture in, right? And also, there's something called, let me just turn on the outline so you can see what it looks like. This is what it's really doing. It's really putting these outlines around the file, right? And I can add different trim levels. So I can add some margin. So you can see there's different spaces between the objects if I want or not on my sprite sheet. I can also take those away. So there's no spaces, no trim. I can go none. I can also go flush. There's different options, right? Let's just go trim. And I can also do other things like border padding. I can increase the border, right? Here's the border padding and so on to move things away. Sometimes for some programs, these things are required, and that's why they have these as an option, okay? So power of 2, 256 by 512, right? It's not just some random number. That's really important, okay? Again, 256, 512, 1024, 2048. Those are the numbers you want to kind of use, right? All right, cool. So we have our image, but now I have 2 files. I have my JSON file. We're going to store our map, where everything is, in JSON file. And we're going to store our texture, the PNG, in a PNG file, right? So our texture atlas. So two files. Here's my JSON file. I want to point it as an example to my desktop, COMP397. Inside this, inside my assets. And you know what? I want to make a new folder called sprites. You can call it Sprite Sheets, Texture Atlas, whatever you want. And I'm going to save this as TextureAtlas.json, right? This is the data for my Texture Atlas. And then I'm also going to have my texture file. Again, I want to go back out to my desktop just to make sure I got the right place. My COMP397, MailPilot D, into my assets, into my sprites. And I want to put it in here. I'm going to call this Texture Atlas. That's what it is. Great. And now when I'm almost done, I'm going to publish. What this does is it writes the file and writes the JSON file. So why do I need TexturePacker? It saves me a whole heck of a lot of time, tons of time. Could you do this by hand? Yeah, you could open up a program, look and inspect where the position of the textures are inside the Texture Atlas, and then make another JSON file by hand where everything is and do it by hand if you really want to. You don't need TexturePacker, but I highly recommend it. It's going to save you a whole heck of a lot of time. Again, free trial for 7 days, but you can, sometimes they have educational pricing as well. You may want to send some information to them and some requests, some more stuff. I haven't seen it though. So what does this look like in your Visual Studio file? So if I go back to Visual Studio Code, I'm just going to close this off. If I go to Assets, I have this new Sprites folder. In my Sprites folder, I have this TextureAtlas.json here. And I have a couple things here that I don't know what the heck this is, right? I have images. This is my PNG. I have something called frame rate, some frames. What the heck is all this stuff? Well, let's look at the Find manual, which is online. So if I go back to Easel.js, and if I look at my Sprite Sheet, let's look at Sprite Sheet this time. So I looked at sprites. Each sprite, going back to TexturePacker, these are sprites. This is a Sprite Sheet or a Texture Atlas. I have textures inside of a Texture Atlas. Atlas, because it's like a map of textures. That's what I have, right? So in the code, going back to the code now, you can see that these are each the position, the width, and the height of each of my objects, plus some additional information. Okay? So what is this information and why do I need it? Well, if I scroll down, you can see that I'm going to get the positions of individual frames, the sequences of frames, right, and the target playback frame rate if I want to. So here's my images. Here's my frames, and it tells you width, height, you know, as an example. Width, height, but also the position. So the first four is X and Y, width and height. The fifth is image index, if you want to give it a handle, right? And the last two is regex and reg-y, which we don't need because we do that in code right now. That's what these frames mean. Animations have kind of a set of animations. So if I want to do a run animation, I can specify that it's frames 0 and 8. So a 2-frame based animation, right? Here's my jump animation. It's frame 9 and 12. It does frame 0 and 8, right? Because I refer to the run, plus frame 2. So it specifies which frames inside my sprite sheet I'm going to use for these animations. So I can make a single frame animation like my button. My button right now has single frame animation, right? Or I can make multiple frame animation like my plane. My plane is going to have 3 frames of animation. And we'll look at that in a second. In fact, let's look at it now. So if you look at my plane, I'm just going to zoom in there so you can see my plane. And you can see that my plane has my propeller on the left and then a propeller on the right. And that's the only change. And then there's a propeller in the middle, right? So 3 frames for the propeller to move back and forth like this. It's going to look like the propeller is moving, right? That's what the animation is all about. And you can see my poor island, how bad it is. It's really bad. All right, so that's cool. That is my frame-based animation. These are my frames, right? And then these are my single frames of animation for my cloud, frame 0. For my island, frame 1. For my plane, frame 2, 3, and 4. But I don't have to put it this way. I don't have to put it this way. I can have my single plane do all this. Okay, cool. So this is kind of a map of where everything is and how I'm going to use it. Let's go back to the documentation for a second. So again, I can have my animation. Here's my walk animation. I can have my frames. And there's also something called speed, right? What speed does is it says, hey, you know, instead of having, you know, a 3-frame base animation, if I have 3 frames and I have 60 frames per second, I'm going to repeat that 20 times. My little propeller is going to move back and forth 20 times in every second. It's too fast, right? So I may reduce that, and I can reduce it from a, it's a normalized value between 0 and 1, where 1 is 100% and 0.5, let's say, is 50% of the frame rate. So instead of like 60, it's 30 frames. So now it's only going to repeat 15 times, as an example, or 10 times. So that's what this does. That's what this is the situation. And this is a good example. Here's the example of what it looks like in the entirety. I create my data. Guess what this looks like? This looks like the stuff I got from TexturePacker, right? I create my sprite sheet. That's the container for the data. And then I create my sprite. And I pass in the sprite sheet for my sprite and the name of my animation. And that's it. And that's what I want to do to refactor my code. My code is now going to use sprites instead of bitmaps, where anytime I use a game object. So I can add animations to them. And I can do things like add explosion animation, particle effects, whatever I want. Any questions around what I'm going to be doing? This is the key of what I'm talking about today, animations. Now, I covered some of this. If you took COMP397 with me, I covered some of the same stuff, but I did it with Unity. And Unity did it at a much higher level. This is much lower level. So you're getting it again, but you know, you're seeing it with code. Yeah. Sure. Well, we'll talk about that maybe at the break. Okay, so let's make this work. So notice even CreateJS says the popular TexturePacker has easel support. Yeah, it's pretty awesome because there really isn't something better than TexturePacker out there that I've seen so far. Not for not for this specific use. All right, so this is cool. Let's see how I'm going to incorporate this in my code. So here's my atlas, but I'm not going to use this. This is just the file. And here's my texture atlas PNG. One other thing I want to save in my TexturePacker, I want to save my entire project. So I'm going to file, save my project. I'm going to save my project in the exact same location, right? So what if I want to add more things to my texture atlas? Maybe I have more images, bullets, explosions, enemies. I want to add them in here too. I can do that. But I need to modify my texture atlas and I need to modify my JSON file. So going in here, I want to open up my assets and then sprites and then create my mail pilot demo. That's what it is. Because it'll save all this. If I have a sprite sheet and I want to make a texture atlas from an existing sprite sheet, it's impossible. You have to cut it up manually. You have to go through and go, okay, so this is where the sprite begins and the sprite ends. This is how wide it is, and you have to do it all by hand, right? And then you can bring it into something like this to do it again for you. That's a lot of work. I don't want to do any of that again, ever, right? I just want to drag and drop, and then it'll keep track of everything for me, and I can always go back into TexturePacker and add more stuff, right? All right, cool. So we can close this down now. So I want to restructure my code again. And I know I'm going to need some stuff in my script. So if I go to my core, I'm going to go to my game. And all this stuff, I want to move into a texture. I already did it. So I don't need the click me button. That was my example. I can get rid of this. I can get rid of my start button, my next button, my back button, my restart button. All this stuff is right now in my texture, in my sprite sheet. So I don't need to do this anymore. And yeah, I'm going there. Same thing with my ocean, though. Notice I didn't put my ocean in my texture. And the reason for that is it's a very large file. It's like 1440 by 480, right? It's really quite large, or 1440 by 640. It's quite large, right? And it doesn't make sense in this case. It's better to load this in. It's not a game object. It doesn't interact with the rest of my objects. I don't recommend large files like this being put inside of a sprite sheet. This is not a sprite. This is a background, right? Sprites are things that you interact with typically in the game, all right? Enemies, players, buttons, stuff. UI can be all sprites, but not backgrounds. Backgrounds are too big usually, okay? So the ocean's gonna stay. But my plane, island, and cloud are already there. So these things can go. So I'm not preloading those. And we're not gonna preload my sprite sheet yet. We're gonna do that by the end. All right, so here's my preloading, and I need a sprite sheet. So up at the top here, I'm gonna go to and I need two pieces. I need my texture atlas data and my texture atlas itself. So here's my texture atlas data, right, which is of type, any. Why is that? Because, okay, so what type is this? What type is this? This is an object, right? What type is all this? It's a type that has images, frame rate, and frames. My images is an array of strings. My frame rate is a number, right? My frames are an array of number arrays. My animations are, well, what the heck is my animations? It's something else. I have to make a class to define this stuff, to give me code hinting in TypeScript. And this is the one place where I say in TypeScript, for now, maybe we don't need it. Sometimes you can use any to solve your problems. If you can't figure out the type in TypeScript, just put any, and it'll work just like old JavaScript, okay? I don't recommend it because it's like saying, hey, TypeScript, I don't want to use you because I'm lazy. And right now, you know what? I'm a little lazy. I don't want to put together a new class just for my data, right? That's what I need to do. Or a struct. Think about it as a struct in C++ or Java. I don't want to do that. So I'm going to leave this alone, and I'm going to use any as my reference type for now, my data type. But I also need some kind of texture atlas file itself, which is going to be of type CreateJS.SpriteSheet. I need a container for my data. I need those two things. And you know what? Since I have my managers, my game manager, I want to have my texture atlas available to me anywhere in my code. So just to be prepared and be more optimal in this particular case for the first time, because we just optimized today. I don't want to de-optimize now. I want to go back into my game.ts and also include that as an option. So I'm going to go down to the bottom, let's say, and put a new public static. I'm going to call this texture atlas, and it's going to be of type CreateJS.SpriteSheet. Okay, so I have that in my manager, my game manager. All right, so cool. So I have this, and now remember how this works. I have some kind of initialization, and I load my stuff, but then there's going to be some place where I'm going to go to my start. And so I want to do it somewhere up here for now, where I do something like this. I'm going to say that my texture atlas is equal to a new CreateJS.SpriteSheet. This is all part of the documentation. And I'm going to pass in my texture atlas data, this part. Okay, but I don't have texture atlas data. Let's bring it in. All right, let's bring this in. And I can get it from what I just got from TexturePacker. Here's TexturePacker, right? This is all the stuff it gave me. I want to grab all this. I'm going to grab all this. I'm not going to load it. Some people ask me, hey, Tom, why don't you load it? You don't have to bring it in by hand. Yeah, there's issues with this. I'm not saying you can't load it. I'm saying there's some other issues around it. It's more optimization, and it goes out of scope for what we're doing today. So yeah, you could. So if I go back up here, and I have my asset manifest. By the way, you could do the same thing with the asset manifest. You could load it, right? But then that's a whole other exercise. And I'm going to put it before my asset manifest for a reason. So I'm going to say something like texture atlas data, which is of type any, is equal to, and then bam, all this stuff. Okay, cool. Images I need. Frame rate is used to define a common frame rate, 20 frames per second, for everything. And that's not going to be necessary. So I'm going to get rid of this as an option. I don't need these last 3 points. I need the beginning, X and Y, width and height, but I don't need these three. And this is a great way of doing it, where I grab these three, and I just clean it up. Any place where there's not zeros, I just want to make it zeros. I want to zero the last three out. They don't need to know regex and reg y values. All right, so this is what my data looks like right now. Okay. My animations. My cloud is frame 0. My island is frame 1. My plane, well, I don't need 3 planes. I only need 1 plane. And I don't need these 2, right? The way I could code this is like this. Frame, oh, let's put it in here without giving code hinting. Frame 2, 3, and 4. Right, so that's 3 frames of animation. But you know what? That's a lot of time I'm going to be spending animating between the 2. So I can also specify that my speed, just like we saw in the example, my speed is going to be 0.5, which means I'm only going to run for my plane animation, my little propeller, that's going to change. It's only going to run 30 frames per second, not 60 frames per second. And I can maybe want to reduce that even more. It's probably too fast still. My restart button is frame 5. My start button is frame 6. Okay, so those are all the frames. I have single frame animations. So all they do is just appear. They don't go away. They don't switch. And I have multiple frame animations. My plane with a switching propeller. That's what it's going to look like. That's the only thing that changes between one scene and one frame and the other. Animation. I don't need this part. This is nice. It gives me an update hash or whatever. Thank you, TexturePacker, but I don't need this right now. Right? I don't need this comma, and I do need to put a semicolon at the end. Are we good? You understand what I'm doing here? I'm just taking the data that I got for TexturePacker, and I made it an object, and I put it inside my files. This is the location, X and Y, of where the sprite is, and this is the width and the height of the sprite. So an example, if I go back to my image, I can see that my first sprite, which is my cloud, is at the top corner. Left and right is probably like 1, 1, and width and height. That's what it knows. So it knows where my sprites are in my texture atlas. That's what this thing does. That's what all this information is. Where all this, the information of where my sprite is, my texture is inside my texture atlas, where it is. In pixels, yeah. Make sense? So I don't have to do that manually myself. That's what the idea is. Okay. Okay. Does that make, so far, are you with me? I know it's a lot, but you need to understand why I'm doing it. That's why I went through that whole explanation, right? All right, cool. So then we passed it in. Here's my texture atlas data. It gets passed in. And now I have to use it, right? Because if you look at the documentation, right, I make a sprite sheet. Here's my sprite sheet. I pass the data in. And then I use it by calling the name of the sprite. I don't have sprites right now. I have bitmaps. That means I have to modify all of my game objects to make them sprites. Right? They're bitmaps right now. So if I want to go, I'm going to start off with I'm going to go into my game object here. And here's my game object.ts. Notice at the top, it inherits from CreateJS bitmap. I want this to inherit from CreateJS sprite. Now it's going to have a problem because the sprite takes in some other weird data. I don't need to use my asset manager anymore. I just need the name of my sprite, right? And I need the sprite sheet, which is managers.game.textureatlas, right? Those 2 pieces of information is what I need. So my texture atlas and the name of my sprite. Okay, so I've modified that one line, right? So that now my game objects are all sprites. I have to make some other changes. So let's take a look at cloud. Does it work for cloud? Well, I'm passing in cloud. So it says, hey, I'm using my sprite sheet and the word cloud. Cloud is the reference to my frame of animation, the cloud animation. The cloud animation has 1 frame. So it's just going to show the cloud. That's what it's going to do, right? And it works for island, and it works for ocean, and it works for all the other ones. You don't see that there's any errors anywhere else, okay? We didn't add ocean because ocean is not a game object. Ocean is something else. It's a background, right? And we want to make it so that button is also part of my things because we added those 2 buttons, my start button and my restart button. Right now, it's not even a game object, but we're going to make it so. We're going to go here, And we're going to say that, and you don't have to do this. You can make it so that it's not a game object and just a sprite. But I want to make it a game object for a couple of reasons. So I'm going to say that it extends objects.gameObject, which means now my buttons are also, they have additional data. Because remember, we're using a monolithic GameObject class. We're not using the entity component system where we can only attach things that we need, right? The monolithic GameObject class attaches it everything. It's like a big container of everything you need for a game object, right? And it's a little less efficient, I would say, than everything else. But here's something we don't need anymore. We don't need this manager's game asset manager get result. We need something else. We need texture atlas, and we need to pass in a reference to, sorry. We need two things to pass in, the texture atlas itself and the image. That's what we need. Okay, so that's because if we make this an object, actually we don't have to do that. I'm sorry, we just have to pass in the image because it does it as a superclass. And we don't need this anymore either because this part right here, this regx and regY, is being handled by the game object superclass. So now I've saved some stuff here too. So on one hand, my mouse button or my buttons are bigger, but on the other hand, I've just saved a little bit of headache. All right, so everything is good, but I know I'm going to get an error. I know it because I did this in the first class, not because I would have figured it out ahead of time, right? So I'm going to go up here and save all. And we did a lot of changes, right? But I want to know where my errors are going to be, right? Because I'm going to get some errors. Notice there's no problems in the scenes. I didn't change any of that. It's just the game objects that changed, right? So why am I getting this error? I'm getting an error now. If I go back to this, you can see that this is blank. Okay, help me troubleshoot. Alexi, I want you to use your troubleshooting powers to help me troubleshoot the problem. See if you can figure it out. Inspect. Okay, here's my console. I know. I'm just telling you other people. F12 is the other way to do it. My F12 won't work properly because I'm using a Mac. And I have other things tied to it, sorry. All right, so, whoa, what the heck is this? It says, failed to load resource. The server responded with a status of 404. So texture atlas wasn't found. Why is that? Well, that's a good first step. I'm going to go back to here, and I'm going to go back into my game.ts. And up here where I load my manifests, I'm getting it to point to this. And of course, that can't be correct because this file here, game.ts, is inside the core, and my texture atlas is inside assets / sprites. So this is wrong. So let's redo the path. And maybe take care of that problem. And this is the first problem, right? And now I have another problem. It says, well, my button is not a constructor. What does that mean? Lexi, my button is not a constructor. What does it mean? Well, what does it mean? Yanko, what does it mean? My button is not a constructor. Yeah, my button is not a constructor. What do I do? How do I troubleshoot this one? Oh, well, I can start looking at my button. Let's look at my button. Okay. So maybe I did something wrong, right? I can actually click on this thing right here. Right here is my button is not a constructor, and see what it says, right? So I go to my TypeScript and I go down and it says, hey man, new objects.button. If it says this is a problem here, and you know that's a problem. Why is this a problem? It says uncaught type error. Objects button is not a constructor. Wait a minute, but I do, right? Because if I go here, by the way, I'm fooling with you guys. I know what the problem is, right? But I want you to figure this out because you're going to get an error like this. That's why I'm showing you this, right? So here's my button. Hold on. My button has a constructor. It's right here. Look, image string X and Y. And if I use my button constructor in my scenes, right? In my start scene, I have a button. Here's my button right here. Look, objects.button, new objects.button, start button. So string X and Y, same thing. So what's the problem? There's no problem in my code here. Huh? The module button, no, it's there. That's not, you're barking up the wrong tree. Come on, think about some other things. The button constructor does not exist. The button constructor does not exist. Well, button inherits from GameObject. And if I right-click on GameObject, if I go to definition, right, it's going to take me to my GameObject definition, by the way, right? Well, no, here's the GameObject constructor right here, right? So somehow this is not working. So button is not a constructor means somehow it's not a GameObject, or it doesn't know about GameObject. Wait a minute, it doesn't know about GameObject. How can a button not know about my GameObject? It's here. And this is where sometimes you need to know. You're not going to figure this out so easily, guys. The reason why this is not working is not because my code is wrong, but because the order of the code is wrong. This is one of those kind of errors. Okay, it's an outside type of error that you would never get unless you understand, you know, the way I've done this many times. So I know when I got that error, I was like, oh crap, it's that. And here's where I want to help you. So if you ever see button is not a constructor or something is not a constructor, it might mean that in your index.html, it's in the wrong order. Look, here's my button on line 35. I declare my button. But wait, my object, GameObject, is on line 37. That means my button is trying to access my GameObject that has never been declared yet. So if you don't believe me, if I take my button and I cut it out and I put it down here, right, where before my GameObjects, right, and I press save, okay? And just to make sure, I want to also do my references. So I want to go into my references. Those have changed too, right? Because I would have realigned my button. And you're going to be mad at me. I know. Alexi's already getting mad at me saying, this is why I hate JavaScript, right? But please don't be mad at me. It's not because of that. It's because you have to understand what happens in the index.html page. Index.html creates a cache, right? And it happens in order. It's like C++. Right? Or you have to define things in order. If you don't define you don't bring in the code in the right order, it doesn't know about it. And that's why I create this reference file, and that's why I create my index.html in the right order. Later on for us, we're going to make one file, and we're not going to have this problem as much, right? But for now, GameObject is a dependency for button, and so therefore it has to come first. Just like if I was programming on the web, and I was using, Bootstrap, I have to have jQuery come first. jQuery is a dependency for Bootstrap. GameObject is a dependency for button. And that's why it didn't work. And to believe me, if you don't believe me, I'm just going to save all this. I haven't made any code changes, just the order. If I go back to here, right, and if I refresh, this should fix the problem, right? It should fix the problem, I said. And this is the thing that I had a problem with before. So two things that can happen here. Either I didn't save everything or there's something else I missed this time around. All right, so here's another one. Cannot read property, get animation of undefined. Okay. So this means that there's some object that I haven't used, that is not in play, that I'm trying to access. Something that's named differently. That's what this means. Okay, so one thing at a time. First of all, make sure that you have everything saved and close it all, right? That's the first thing you have to do. Next, I want you to go over here and let's take a look at my game.ts file. So this is where I would go bark up this one. Now this one is a new one for me. And I got a new one this time around compared to last time. So let's figure this out together. So here I load my texture atlas, right? I pass in the texture atlas data. It's called Ocean, Engine, Thunder, and Yay. That's what gets loaded in my load queue. And up here, I have this part right here, my texture atlas PNG. Okay. Well, this means that I should be able to see my texture atlas PNG, right, on my scene. If everything goes well, if I went to my, here, my local host, and I put in something like assets, sprites, I did this earlier, texture atlas, right? I should be able to see my texture atlas, right? Assets, sprite, texture atlas. If I can type properly. I should be able to see this. So now I know this is loading right because I can get to it from my website. It's just a website, right? So I can get to it, so I can see it. That's number one. Okay, so I know it's not this. I know I can load my sprites, right? Now I'm going to check the name of the sprites. cloud, island, plane, restart button, and start button. Those things all have to be named correctly. So I don't think I changed any of that stuff, right? And it's going to be probably in my start scene. So I'm going to go to my start scene, and I'm going to go here, and let's see what it's loading. So I've got my start button. Okay. That's the first thing that it's loading. If I was to comment this out, right? So let's just comment out the start button for a second. So no start button. I don't load the start button. Okay, no start button. Does my scene load? I'll go back to here and go back to here. And does my scene load? This is the thing. I'm telling you, this is what we have to do. Because if that doesn't work, get animation of undefined, what the hell does this mean, right? And you notice that all the rest of them are just updates that are undefined. So there's something I've done wrong, something that I've missed, right? And it points to the place. Like this, the great thing is it says, well, this is easel.js, but this is something like game.ts91. Okay, let's take a look at where that is. So game.ts91. So in my current scene, so something in the scene, that's what's causing the problem, right? This is how we're tracing it, right? So something in my scene, something in my start scene is causing the problem, right? So objects.label, my start button click, right? No problem. What did I mess up? Because my update function is here. It was working, right? My ocean.update. Did we mess up ocean? Did I not load ocean? I think I did. Ocean. Yeah, see, that's what I'm saying. You have to check everything, right? Because I've made a lot of changes, right? Here's my 21 changes, right? So I got to see what I've done here. So here's my texture atlas, and you load Q texture atlas data. I'm passing it in. So now I should be able to. Wait a minute. I never used texture atlas anywhere, right? I didn't pass it into my game. That's it. So managers.game.textureatlas is equal to texture atlas. I never made that reference. I created it, but I never made it. That's the problem. Okay? Guys, I know. But this is what it is. You have to know your code, right? So I have to think about, wait a minute, do I have it? Yes, it's there. But now it's not there, right? Let's see if this works. Still giving a problem, but something else now, right? Did I save it? Okay, here's texture atlas, right? All right, cool. So I've saved it, right? I've saved my entire scene. That's the next part. I got to keep going to see what the next part is. So here I've loaded it. Here I do my load queue. Here I start. I go to this part. I'm just tracing to see if I've got everything done. I've done this part, my asset manager, my texture atlas. And now we do some testing. So let's see if I can see my texture atlas here. So in my scene, in my start, just before my ocean gets loaded, I want to see, can I see my texture atlas? So I'm going to do a console.log and pass in managers.game.texture atlas. Do I see it? Right? Can I see my texture atlas? Can I see my object? Because if it doesn't come here, it's not going to go anywhere else. All right, so we reload. And hey, there it is. See it? So I know I'm getting it. I know I'm getting it right here. There it is. So I got my cloud, my island, my plane. See, I got my object. This is my whole object here. And I can inspect in there and say, hey, do I have my animations? Here they are. Cloud, island, plane, restart button, and start button. That's cool. And here's my data, right? This is all good. Here are my images for array number 1. Here's my first image. And I should see all the information for my texture atlas. There it is. So this is all good. I'm getting all the information from my object inside my scene. So here, it works up to this point. Okay. How about my ocean? Can I see my ocean in my start? So console.log. And then I'm going to pass in my this._ocean. Can I see my ocean? Okay, so I do one of these. We'll keep this one because I want to see if I can see my texture atlas and my button in a second. If something else is wrong. All right, let's redo that. And when we save everything, we still see some errors. It looks like a lot of errors, but they're just repeats. Okay, so I see my ocean. So my ocean is there. Here it is. And let's take a look at my images. I want to be able to, I should be able to see my image, right? My ocean image. So here's my parent and my rectangle. Did I mess up something? Here's my image for my ocean. And here's the blob that I got. This is good, right? This blob, what it is just my my ocean blob itself. So if I took this thing right here, this is a good example, and I took it the way it is, and I copied it, and I went to my another page, and I pasted it in, and I pressed enter, I should be able to see, you know, my ocean if I can. So let's try and do HTTP. Let's see if I can get that. If I don't see my ocean, right? Now what it's trying to do is it's trying to see this particular object, right? So that's something's wrong. Something's wrong, right? Right? Now that could be it. So if that's true, if it's not seeing my ocean, if I'm not barking up the wrong tree here, I could be, right? Then it wouldn't work because I can't see my ocean. And so let's comment that out too. Let's just make it so that it's not, I just want to see errors. So I want to comment this out. I want to comment out the updates. And I want to comment out the this part. And if the reason why I'm commenting it out is to see if it still works, right? Okay, the start button, because that start button doesn't exist anymore. I've commented all out. Okay. See, something's wrong with my ocean. I didn't have a problem with my ocean before. I got a problem with my ocean now. Well, let's see. I didn't change anything like that. Right? I didn't change my code. But somehow my ocean is not loading anymore. Before it was loading fine. Now not. Right? But this works. Well, then let's put back my button now. So I took away my button. Let's put it back. Let's see if that's a problem. So if I can see my button. So going back to this, I want to, and again, I know you might troubleshoot differently, but the reason why I do this is because if I do this, then I can isolate what the problem is. That's what I'm trying to do. I'm trying to isolate my issue, right? Trouble isolation is one of the first things you want to do with debugging, right? So what's my trouble? Isolate the trouble. Make it so that I can see what the issue is as much as possible. Start button. Whoa, what the heck? The ocean works here, and everything else works, but not on my start scene. Right? My start scene isn't working for my ocean, but everything else is. That's pretty weird. That's a really weird bug. That's a bug, right? Because if I click start, then my ocean shouldn't load here either. So how come it's loading here, but not loading everywhere else? This is another problem. This is another kind of problem that I can tell you what it. I think I know what it is. Okay, I just want to put this ocean back. So here's my ocean back. Please don't get mad at me when I tell you what it is. I know that Alexa's going to get mad at me again. He's going to go. He's going to say, "I hate JavaScript." It's like let's program in Java. Java's my friend, right? And I don't disagree with him in terms of the robustness of the language and how you can troubleshoot. But we have to understand again what's happening. So going back to my game.ts, this is what's happening. Okay, I'm just going to make this bigger so we can see it. Okay, so if I go back up here, here's what I've done. Here's my ocean, my engine, my thunder, and my yay. All right, and this is my asset manifest. And then what I'm telling it to do is do this. Make a new texture atlas and pass in my texture atlas data. Before I do my asset manager, I'm telling it to do that. Okay? Here's my texture atlas data. If I was to comment this out, so I don't have any texture atlas data at all, no texture atlas at all. I'm going to have a pile of errors now, right? Wait, look, it came back. How did it come back like that? Wait, let's put it back. Hold on. And you're going to get really mad at me when you see it again. Hold on. It's a caching issue. That's what it was. Nothing was wrong with it at all. Right? So sometimes what I could have done differently here, and I wasted some time, 20 minutes or so figuring this out, is I could have loaded this in another browser. That's another option. It doesn't make sense. I didn't change anything. How come it's not working? Try another browser. No, that browser doesn't have my cache, so my cache wasn't cleaned, and that's why this happened. Okay. Wow, everything's working. It's a great place to take a short break. We don't have a lot of time because we have about an hour or so left after this, right? Let's take a short break, about 10 minutes, go to the washroom, do what you have to do, and come back. And then when we come back, we're going to change our fonts. I want to change these fonts. And I want to see the plane, this thing here, what it actually does. Can you actually see? Let's try that again. And can you see the plane, right? Can you see the plane rotating its propellers? Right? See that? See? Yes. That's what I'm doing. I'm swapping out the images. Uh-huh. 10 minutes. Okay. So you want to change the barrier to a destroyed barrier. Okay. So the question was, for people who are watching online, so what if I want to swap the image? Now you're talking about a bitmap image, right? How can I swap a bitmap image? So I have to create a new image. So my image, let my image is equal to new, capital I, image, right? And then point to that image with a new path to the image, right? Whatever that path is. And then I'm going to say that my bitmap.image is equal to my new image, right? And then it'll swap. It will replace it. Now, the problem with it is it needs to be redrawn afterwards, too. You have to do a stage update, right? And it always doesn't always work because you're using a bitmap. Remember I told you why I'm using sprites? Sprites are for animation, for swapping images, and for like replacing the image with the other image. So what you can do is, let's say, for example, you have 2 frames. Your regular thing you're not destroying and the destroyed one, right? You only play the first one. What you have is you only play, you go to and stop. So what you can do is when you do the object, let's say the object is called wall. You can say the wall, I want to add child wall. And then when I add the wall to the scene, I want to say wall dot go to and stop, right? And when you do that, what happens is it stops in that particular frame. So it doesn't go to the next frame. The next frame is the destroyed wall, right? And then when you want to play the other one, you want to show the other frame, you can say go to and play that one, frame 1. So frame 0 was the normal one, and frame 1 was the destroyed one. You could show only frame 0 and then play frame 1. Alternatively, you can have both versions of the wall, frame 0 and frame 1, but 2 different things. One is wall and one is destroyed wall. And then what you can do is just literally remove the one wall and put the other wall back in, the destroyed wall. I'm just trying to figure out which way you want to do it. And I have to look at your code to try it out. All right. But sprites is it's much easier for you to use sprites to do what you're thinking about than to use bitmaps. Bitmaps, you have to replace that image, and sometimes it doesn't work. Okay, let's take a short break, and when we come back, I will go on and change some of this. I want to go over the code. I'm going to push this to GitHub before I stop. So I'm going to go to Visual Studio Code. I've done 20 changes. I'm going to stage all the changes, and I'm going to say added sprite sheets. Or I'll say, added sprite sheets. Yeah, that's that one. I'm pushing that one now. And let's stop and we'll come back in about 10 minutes.